Welcome to another Beta Talk podcast. This is a very special one. It's going to be one where I sort of introduce technology, VDI 2035 technology. It's being talked about a lot in the UK at the moment, especially on social media. I've got some great guests with me. I've got my good friend Si Poskett. Now, Si Poskett is my specialist that I use around this area. If you don't know Si from social media, he's been sort of the guy in the background that sort of helped teach some of the other ones that are quite well known, like Steve Calvert and people like Craig Brooks. I've also joined by my co-host today, which is Joe. Joe's the head of content at the Installer magazine and obviously helps run the famous Installer show. And I'm joined by my friend Michael, who's the director of business development from the company Magnetic, Michael's German and based out in Germany. So we're going to be speaking to him about what VDI 2035 is. So actually, probably that's best where we should start, Michael. What is VDI 2035?
Well, let's start what the VDI is. This is the Association of German Engineers, and they're trying to promote the latest technologies and gather it and try to define a guideline and how to put it into action. This is what it basically is in short words. And the VDI 2035 describes the quality of heating water, meaning what specifics should the water have, that there's no corrosion and the optimization of thermal transfer.
Now, there is actually, wasn't there, when did that 2035 come out? What year was that? Because there's been two, hasn't there?
There have been two, yeah. The first version was 2005, which was only talking about thermal transfer. Then softening water was the technique. And the second one, which is the current one, was 2009, which also prevents corrosion. So this is the version that's actively in place for 11 years now.
So I just want to sort of reinforce that for sort of any of the lay listeners. So the first one, was that 2005, we said? That was softened water, which, yes, as we know, doesn't actually reduce conductivity in the water, does it? So obviously corrosion can still take place, isn't it?
Exactly. It just helps scale not forming. So you will have no scale formation on your heat exchanger. But the conductivity, which is one of the main drivers of corrosion, is still the same. And
that's what 2009 VDI actually then addressed. Now, Si, you've known about this for a while, all this sort of this VDI, and you were taught by someone, and also you use this, I think, don't you, when you're actually out installing, or when you've been out installing, you sort of use this method.
Yeah. I started getting involved with VDI, I suppose, 2015, 2016. Bought some decent test kit so I could measure my local water and make sure I was doing the right thing for my customers. And you know what, we're 4 years down the line now, so I know I've got systems out there that have been filled with VDI tolerant water, if you like, or within the VDI boundaries, and it seems to work really well. It's just a very simple process. As long as you measure, monitor, you can keep an eye on it.
Yeah. When did you come across the technique, Simon? When did you hear about it to begin with?
Through social media, really. There was a Dutch guy, Remco van Triest, that kind of sparked an interest a few years ago, and Remco's kind of guided us through the process. And there's a few of us, you know. There's a Wayne Kirby out there. He's still fitting the kit, fitting boilers. I've kind of stepped back from that a little bit these days, but yeah, we all kind of went on a bit of a journey about 4 or 5 years ago, and started learning about the techniques. And I must say, it's easier.
You also had there's an engineer on social media called Viatech, Chris. Now, Chris he was talking about this back in 2012, I think, and very passionate about VDI 2035. And if you're a consumer listening to this and you're in the Kent area, I think that's where Chris is from, you know, highly recommended engineer, does renewables, all sorts. So he was talking about it, and obviously over time, it's now become quite we're starting to see some communication about it on social media. And obviously that's when you kind of approached me, didn't you, Michael? Obviously you saw it's something I'm passionate about. and you approached me because obviously you've got the technology that does this, and you're based out in Germany, and we had a meeting. We've had a few meetings, haven't we? What is the sort of technology that you are bringing to the UK? If you just sort of describe that.
Well, the technology is the technology to demineralize water, which is a simple process. So the process is the following: you have a mixed bed resin, which takes the minerals out of the water to manage conductivity. Just to get the value, conductivity should be below 100 microsiemens per centimeter. If you reach that value, you're pretty safe. At the same time, you have to manage a pH value. That's very sensitive too to corrosion. So the heart, if you will, to produce the right water is the resin. And this is why we spend a lot of time getting the right resin that will reduce the conductivity, number one, and you get the right pH value.
You know, and we want to talk about the pH value. There's been some discussions on social media about the pH. I did a little thing the other day just to sort of make people aware that the ideal pH for VDI 2035 is 8.2 to 10.
Right.
And we do know that some other people that do this sort of equipment, they will actually, their resin sets it at a particular pH to start with, doesn't it, around 8.3. And magnetic, you chose not to do that. So can you sort of talk to us about that a little bit?
Yes. So just to understand, when you demineralize water, the pH will always be around 7. So this is not the value you want to have because it's 8.2 to 10, as you just well said. If you have aluminum, which is more sensitive, you need to have 8.2 to 8.5. So a very narrow window. That's why we spent the research on that. No matter what material it is, you can always use our resin. So number one, you reach pH 7. And then there's a process kicking in. It's called self-alkalization, which means the water reacts with the material in the heating system plus heat and brings up the value to the desired 8.2 to 8.5. That's what happens. It's also described in the VDI 2035 that this process is allowed to take up to 12 months. So there's no need to be worried when you produce 7 because this is what you get out.
And you've seen some of your systems self-alkalize as well, haven't you? So, I mean,
Yeah. I generally, I'm blessed with not very hard water here, so I never went to the full demin process. So I filled with tap, and you find the water softens over the first year because obviously we go from 200 ppm, go down to about 80 ppm after the first year because all that scale is unfortunately cooked off onto the heat exchanger, which, you know, that's not great, but you know, as long as it only happens once, it's okay. But I find the self-alkalization goes from comes out of the tap at about 7.3 here, 7.4, and it just sits at about 8.5. Perfect. And it usually only takes a couple of months. You do need a full heating season, really. If you install a boiler in May, the heating's not going to be on. So, you know, you do need to sort of cook the water as best you can during the summer months. So I think that's why VDI says gives it a full year to achieve. So it's had a full heating season, doing its thing.
It's that because obviously people like your friend, our friend, good friend, Steve Carver, obviously, and hopefully lots of other engineers, we're going to start moving across to low temp heating systems. Does that make it difficult then for the water to self-alkalize? Because obviously we're not, you know, you normal. I say normal. The systems that we're all used to are quite hot, so they're getting hot. Now, when we sort of transition to sort of the low temp heating systems, this self-alkalization, is that going to be a problem? Do anyone think?
I think you need to run it at over 60 for as long as you can
on a commissioning sort of process.
Commissioning. In theory, you know, you may be only designing a system that will only max out at 50. So self-alkalizing, I don't know, maybe Michael will have a better opinion than me, but
we have quite some experience with heat pumps in Germany, which don't get that warm, 45, 40 sometimes, It just takes longer. So it's maybe not 3 months, but it's 9 months.
Okay.
But the product kicks in, so there's no issue there.
I know we've got another question sort of from a viewer. Obviously, the mixed bed resin, there's two ways you do it, Michael, isn't there? They can have a cartridge. It's called the VET 1000. You can find that on Ricky's site, the Thorough Flush site. And that you also do a stainless steel sort of, it's called the Mobile, I should know what it's called. What's it called? The Mobile Plus?
Basic mobile.
And that's where you can actually just put your resin in and obviously use it. And then when it sort of it comes to the end of its life, you can just get rid of it. And obviously there's a couple of benefits to that, I suppose, because I mean, ideally people, you would use your resin, but they can choose other resins, I suppose, if they think there's, but it's just a nicer way to do it, isn't it? They haven't got to keep replacing cartridges in it, I suppose. It's just a different way to do it, isn't it?
Well, yeah, it depends on the job you want to do. The cartridge you normally use when, you have a little bit of topping up or a smaller system, you can use the cartridge. But if you want to have a bigger system, like in a hotel, etc., you just take a bigger tool. In the end, it's a tool, and in the tool, there's always a resin in there. That's that easy. It's just depending on the job, what tool do you use?
And I also want to sort of say, because I know people all around the world, they've been a little bit concerned about sort of plastics getting to the ocean and stuff like that. Now, we've talked about this. There's a reason, sort of, because this does get just disposed of in general waste. Right. Some people have asked me, can't it be recycled? And you were telling me earlier about the acids that have to get used in that. So it actually becomes a bit of a...
Mm-hmm. Well, technically you can recycle it or regenerate it, which is the correct term for it. But first of all, it loses capacity. The resin, let's say, before you get 1,000 liters out and then you get 800, you don't know. That's number one. So high quality resin will never be regenerated resin. Plus, to separate the resin beads, you need chemicals, you need acids for it, which is not exactly environmentally friendly. That's why we said these two reasons are good enough for us to just use fresh resin and always have the highest standard.
And I know, Simon, you test your water, don't you? I mean, you've got a kit, and I think you're getting one of Ricky's kits soon. I mean, can you see or envisage engineers sort of getting used to testing the water a little bit more? Obviously, historically, we just bang water in, don't we? We just fill it up with water. But this whole process of testing its pH, testing its conductivity, can you see that being something that becomes quite the norm?
I hope so, because I think if you really want to understand the corrosion process and understand your water, you need to measure it. Otherwise, you're just guessing.
Yeah.
And you can really see once you kind of learn the basic science, and it isn't rocket science. It's just a bit of water and a few values, and monitoring it over time as well. Sort of unlocks a little bit more knowledge, because you can see what's happening over time, and you can see that you're not causing any corrosion. Typical systems in the UK, you've got steel radiators, so iron, and on other more conventional systems, shall I say, you'll see the iron rise each year. You'll start with a nice clean system, flushed. Iron will be near 0 parts per million. Second year, first year you'll maybe get to 3 parts per million. Second year, 5, and onwards and onwards and onwards. And you can get, I've seen systems that got 20 parts per million iron in them. The water's crystal clear, but there's still plenty of iron in it, because you're still corroding the radiator.
And that signals corrosion, doesn't it?
Yeah. To me, it does. But the systems following VDI, you just don't see that rise in iron. And that to me tells me that it's doing the right thing.
What do like homeowners and end users think when you like go in and talk to them about this sort of stuff, and do the water testing, and do you give them a report and stuff? Because it sounds like it sounds like it's impressive, doesn't it? This is a potential issue. Here is some data to figure out. This is why it's taken. I don't know how long it takes to kind of do this sort of stuff.
It doesn't take long to take a few readings, and I think it's won me jobs. If I'm going to do a boiler swap survey, I'll quickly test the water. And you get a sense for what things are going to be like. There's certain housing estates that have got horrible plastic non-barrier pipe in them, so you can pull off this black treacle out of the heating system, and it impresses people. They don't really understand why you're doing it, though. That's the difficult, and I think it's a hard sell to sell this thing for more money. I think, and that's one of the reasons I think it hasn't really taken off. But what I really like about the magnetic stuff, it's very accessible in price, and you can fill a heating system for I'd say around about £10. So it's no more expensive, if not cheaper, and easier. And the only other thing I guess it does do is tie you into the install, because really you don't want the customer topping it up with fresh water and things like that. So if they
that's something worth mentioning. I mean, we've been talking about this technology, but we still need engineers to know it's all about good design. You know, make sure you got your expansion correct. You know, make sure your expansion vessel size and things like that, so we aren't. I mean, going back to Joe's point, I mean, can you see or envisage like customers that like getting a report? So let's say that you've gone around, you've thermal imaged all the radiators, and they look all horrible, and that's in their report, and then you do this water analysis, that's in their report, and then you do the thorough flush, and then you go around with your thermal imaging equipment again, and it's all looking nice and clean. I mean, is that something that could be a good selling point for an engineer to win work, I suppose? And because obviously the engineers that are doing good work, the real thing I feel sad for them about is their quotes are always going to be higher. And, you know, they really want to do this good stuff. They want to do it to the best of their ability, what they're all learning about. And yet their quotes are going to be higher. Not always much, but so there needs to be something that just tricks that consumer's brain to think, well, yeah, actually, that's why it's high, because they're doing such a good job. And I've got a kind of report here to prove that. Mm-hmm. I mean, is that something you can see happening?
I think a lot of installs are very, very price driven, aren't they? But I don't think doing the right job should cost any more money. We've all seen installs that are terribly put in, and they charge the earth. Yeah. So unfortunately, it's the customer that's losing out there. I think there's a big thing in the UK market where the customers he's gas safe registered. They're all the same. All these guys are the same. They're all at the same level, but I don't know. I don't know how we get the guys that are doing the right job the kudos for doing it, really.
Well, I'm hoping it'll be a kind of a natural progression. That sort of. I mean, Joe obviously sees it. I mean, Joe, when I first got onto social media, Joe was. Well, I've actually told Joe this in person. He really impressed me, because obviously I know the magazines very well, but this was the first time I'd seen magazines using social media, and Joe was the first, without that, the first one doing it. Bringing installers together, they were all engaging and exchanging all this information. And within a couple of weeks of me being on social media, because I'm quite an old git, I didn't really want to be on it, but I was thinking, wow, this is unbelievable. They're learning so much stuff. And it really was. And I think what's happening is you're starting to get this organic sort of, these engineers really want to do good jobs now, and they want to be proud of their jobs. That's what a natural engineer actually likes to do.
Exactly. And it re-inspires you in the job. You can get quite demoralised doing the job, really, because you get no thanks for it. You're up against
people don't understand, do they? That's the thing. They just want a hot radiator at the end of the day. It doesn't matter what the system is. That's it, isn't it? You just want a piping hot rad, and then it to be probably as cheap as possible.
Michael, have you got a website people can go to? I mean, obviously, Ricky's thoroughflush.co.uk is one website they can go to, isn't it? And I know you've been working on. I always think every German person could speak English, but that's very silly of me to think that. But I know you speak English well. But you've got an English site now, I think, up and running, haven't you? That people can go to and have a little look around.
Yes, it's magnetic-online.de, and then you can just click on English, and you will find all the information in English.
How common is this sort of stuff in Germany, this way of doing things? Is it because it's obviously very new or relatively new to the UK market? Is it? And we hear a lot in the industry about how kind of Germany especially kind of sets a standard for their heating engineers. They hold their engineers in higher esteem. They're engineers first, and they do a lot more things that are like this, like not outside the box, but maybe going above and beyond what people would in the UK.
Yeah, well, the guideline is in place for 11 years now. So of course there was a learning curve, if you will. Not everybody jumps in at the first minute. But the thing is, the big boiler manufacturers that tie their warranty claims to the VDI 2035 means when the boiler breaks down, they will send a technician, take a water sample. If it doesn't meet the values, tough luck. So you think about it, if you want to have your heating system filled with proper water, or if you want to save 50 euros and not have the proper water.
Yeah.
So it's a standard if you want. There are some which still don't do it, but it's always the case. But I would say it's the standard if you want to be on the safe side.
Yeah. And I think we're right at the bottom of that ladder, and
Well, yeah, but from a sales point of view, which you mentioned before, how do you convince a person to spend 50 euros more? It's easy if the engineer explains why this is necessary. So what our installers do, and we give trainings to installers. They will take a water sample from the tap. And said, I don't know how hard your water is, but the water which should go into your system, conductivity should be below 100 microsiemens, otherwise corrosion is likely. Then with a customer, they take a water sample. It takes 30 seconds with a conductivity meter. And then it's 800.
Yeah.
Then you have a picture. It should be 100 and it's 800.
And you kind of get the consumer involved in that whole measurement process.
Yeah, they have to understand what the consequences would be to save 50 euros.
Yeah. And that's what I kind of did when I was trying to, sell the technique. You get, nobody's ever done this before.
Mm-hmm.
You get that old classic, but you win people over with it. You do win people over with it.
I mean, one of the hardest. I mean, I always used to say this when I was teaching young people in colleges and prison. But one of the things that's not taught is how do you interact with. Mm-hmm. We are in a very diverse country. The UK is probably one of the most diverse countries on the planet, and no customer is the same. And you don't get taught how to because it's hard. It's hard work. It really is hard. I'm very eloquent when I want to be, and fairly astute. But I found it really, really hard. Some people find it quite natural. Actually, they find it very natural. And you have to sort of you become an actor. You kind of you act differently with different sorts of cohorts of people that you meet because you've got to try and get this information across. Some of them, that their time. They haven't got a lot of time, so they don't want to hear you talk too much about things. And other people want to spend days with you, wanting to know about every single thing you do. It's so hard for the engineer. And what people don't realise is our engineers have to know so much knowledge. Absolutely, they really, really do. We aren't. No disrespect to plasterers and other trades. Electricians and plumbers have to know an incredible amount of knowledge, and I don't think our general public understands that yet. I'm seeing some of the early adopters that I speak to that like renewable technology. They now get it. They really now get it. That's actually quite a technical trade. But your average person in the UK just thinks it's no different to a painter coming around and painting your house. But it's incredibly different. And there's no disrespect to painters. That's a great skill, but it's different. The knowledge that they have to know is incredible. And obviously this is going to be more knowledge. But like we've tried to keep it simple. I know Magnetic are trying to keep things very, very simple. You test your water going in, you demineralise it, test it, like what Simon's been doing, and kind of away you go, really. Right. Well, I think we've sort of covered it. We'll probably be doing some more little short beta talks around this sort of area. So if you ever want to know some more information, please get in touch with me. Simon and Joe, you'll also find on Twitter. Follow Installer if you don't follow them. Get their magazine. They can sign up to your magazine online, can't they, Joe? Yeah.
It's all installonline.co.uk. It's the one big hub for everything that we're talking about.
And obviously you can visit Michael's website, magnetic.de/EU, I suppose, isn't it?
Magnetic-online.de, and then just click on English. So that's the easiest thing.
Super duper. All right, well, thank you ever so much to my guests for joining me today, and I'm sure we'll see each other soon.
Thank you.
Thank you.
Cheers, guys.
All right.